Okay, this question is on cubic graph optimization, grade 12 area, May June 2021, grade 12 exam question. Okay, the question is from paper 1, question 10 from DBE. Okay, this is the question 10. You have 10.1 and 10.2. On 10.2, you have two sub questions. Okay, you can see that the total is 13 marks. Okay, let's get started on the next slide. Okay, let's get started with 10.1. Okay, this is the question 10.1. 10.1, the graph of f of x is equal to ax cubed plus bx squared plus cx plus d as two turning points. Okay, the following information about f is also given. F of 2 is equal to 0. The x-axis is a tangent to the graph of f at x is equal to -1. F prime of 1 is equal to 0. F prime of a half is greater than 0. Okay, without calculating the equation of f, use this information to draw a sketch graph of f. To solve this question, let's get down the information that you are given so that you can have an idea of what you are requested to draw. Okay, let's get down the information that you are given. You are given f of 2 is equal to 0. This tells you that you have the x-intercept at 2. At the x-intercept, y is equal to 0. Okay, from this, you can tell that you have the x-intercept at 2. Okay, so the x-intercept is at 2 and 0. Remember, at the x-intercept, y is equal to 0. When you check the second piece of information, you can see you are told that the x-axis is a tangent to the graph of f at x is equal to -1. Okay, you know that the x-axis is a horizontal line. Okay, and the only time that f can have the x-axis a tangent is at the turning point. Okay, because the x-axis is a horizontal line. So from this information, you can conclude that you have the turning point and the x-intercept at -1 and 0. Okay, at -1 and 0, right? From this information, you can tell that you have the turning point and x-intercept at -1 and 0. Okay, let's carry on. Now, when you check this information, you have f prime of 1 is equal to 0. Okay, this is the first derivative. For you to have the first derivative equal to 0, this can only happen at the turning point. Okay, whenever the first derivative is equal to 0, you know that this is at the turning point. Okay, so from this information, you know that you have the turning point at x is equal to 1. Okay, because f prime of 1 is equal to 0, you know that you have the turning point at x is equal to 1. So you have the turning point at this value. Okay, because the first derivative is equal to 0, you have the turning point at this value. Okay, so we are getting all the information down so that we know what we are requested to sketch. Okay, because the question is saying without calculating the equation of f, use this information to draw a sketch graph of f, only indicating the x coordinates of the x-intercept and turning point. Okay, we carry on. Now you have the first derivative of a half is greater than 0. Okay, whenever the first derivative is greater than 0, you know that you have the graph increasing. Okay, so the graph is increasing at 1/2. Okay, or the graph is increasing at a half. Okay, if the first derivative is less than 0, you know that the graph is decreasing. But in this case, you have the first derivative greater than 0, then you know that the graph is increasing, going up like this. Okay, going up, not going down, but going up, because the first derivative is greater than 0, you have the graph going up at x is equal to a half. Okay, so let's get this information down. You have the graph of f is increasing at x is equal to a half. Okay, now you have all the information down. now you can sketch the graph. Okay, so this is the Cartesian plane. You have your x-axis and the y-axis. Okay, you have the x-intercept at 2 and 0. Okay, x-intercept at 2 and 0. This is 2 and 0, right? So you have the x-intercept at 2 and 0 there, and you have the turning point and x-intercept at -1 and 0. This is -1 and 0. Okay, and you have the turning point at x is equal to 1. Okay, x is equal to 1. You don't know what the y value is. Okay, so it's going to be, from this information, you can see that when x is equal to 1, y will be positive. So you're gonna have a point above there so that y is positive, because from this information you are told that f is increasing at x is equal to a half. This is a half, so the graph will be increasing, going up like this at x is equal to a half, not going down like this, but going up at x is equal to a half. So from this, you know that the y value of this point is positive. Okay, you don't have enough information for you to decide what the y value is. So you are going to have a point somewhere there. Okay, let's have the point there. Okay, y is positive because you wanna have f increasing at x is equal to a half. Okay, a half is there, so the graph will be increasing when you have the turning point there, right? You have the turning point there, the graph will be increasing at x is equal to a half, not decreasing, going down. Okay, so you don't have enough information for you to decide what the y value is. Okay, for now, you can put the point above 1. Okay, above 1 and above the x-axis. So the graph will be like this. Okay, like this. Can you see? Okay, so you can see the graph is increasing at x is equal to a half. A half is there and the graph is increasing, so it's going up at x is equal to a half. So this is the graph. Okay, now it's question 10.2 and you have two sub questions. Okay, 10.2.1 and 10.2.2. Okay, O is the center of a semicircle passing through A, B, C, and D. The radius of the semicircle is x minus x squared units for x is in between 0 and 1. Okay, so x is not less than 0 and x is not greater than 0. X is not equal to 0 and x is not equal to 1. This is what the notation is saying. Okay, the value of x is in between 0 and 1. Let's carry on. Triangle AOB is right angled at O. So you have a right angle at O. This is 90 degrees. Okay, let's carry on. 10.2.1, show that the area of the shaded part is given by this. Okay, 5 marks. This is the shaded part. Okay, you can see this is the shaded part. We have this shape. Okay, so this is the shaded part. Now you have to show that the area of the shaded part is given by this. Okay, so the way to solve this question, you can see you have this shape which is a sector, and you have this shape which is a right triangle. So you can get the area of the sector first and then you subtract the area of the triangle and you are going to remain with this. Okay, just in case if you don't know how to find the area of a sector, I have a video for you in the video's description. I have provided the link to the video, so please go check that video. It's going to help you on how to find the area of a sector. Okay, so you have the area of the sector minus the area of the triangle. You're going to remain with this. Okay, so to solve question 10.2.1, you have the area of the shaded part. This is equal to the area of this shape first. This is a sector. okay, area of the sector, right? This one in red, okay, minus the area of this triangle, okay, of this right triangle, okay, area of the right triangle, this one in blue. And then you can see you are going to remain with this shape, which is the shaded part, okay, the shaded part. So the area of the sector, this is equal to, okay, like I said, if you are struggling to find the area of a sector, I have a video for you. Please check the link in the video description where you are going to find a video in which I explain how to find the area of a sector. Okay, so this is your sector, this big part, including the blue part and the red part. Okay, so to find the area of the sector, you're going to start with the area of the circle, which is pi times r squared. You know that, okay? So remember to multiply by the angle of the sector over 360. The angle of the sector is 90, okay? So it will be 90 over 360, okay? So let's carry on. This is equal to 90 over 360. This is a quarter, okay? A quarter, 1 over 4, right? Times pi. Pi is a number, okay? Times pi times r squared. R is equal to this, okay? This is what you are told. The radius of the semicircle is equal to this, okay? It doesn't matter if it is a semicircle or a full circle, the radius will still be the same, okay? So the radius is this, okay? Remember squared. This is the radius, right? Squared, like that. Okay, let's carry on. This is equal to, you have 1 over 4 pi, okay? And then you can expand this bracket. You have x squared, right? And then you have this times this, x times negative x squared. This will be negative x cubed times 2. It will be negative 2x cubed, okay? Negative 2x cubed. And then you have this negative x squared to the power of 2. This becomes plus x to the power of 4, okay? Plus x to the power of 4, okay? So this is how you can expand this bracket like this. You can rearrange this to have the highest power followed by the second power and the lowest power like this. X to the power of 4 and then x to the power of 3 and then x to the power of 2. You can rearrange this, okay? So this is equal to, okay, now you have the area of the sector. Let's get the area of the right triangle, okay? So let's do it here. The area of the right triangle, this is equal to, remember from the lower grades, this is half times base times perpendicular height, okay? You know that from the lower grades, okay? So this is equal to half. So your base can be this and your perpendicular height can be this, okay? You can see this is a radius and this is also a radius, okay? So this is a radius and this is a radius, okay? So your base is this, which is the radius, okay? This. And your perpendicular height is this, which is still the radius, okay? So your perpendicular height is this, which is still the radius, okay? This is equal to, right, a half times this. Can you see that this is the same as this? You can write this like this. So what you are going to get is this part, okay? So you can write it like that. Now you have the area of the right triangle, okay? So finally, the area of the shaded part is equal to, you have the area of the sector, which is this, minus the area of the triangle, which is this. So this is equal to, can you see you have this and this. this is the same, you can write as one bracket. Okay, so I can have this minus this and then write one bracket because this is the same. You can see what we have there and there. This is the same. So I can say 1 over 4 pi minus 1 over 2. I close the bracket. I open another bracket. I put this. You carry on. You can say you need the lowest common denominator. Okay, which is 4. Okay, how many times does 4 goes into 4? Okay, how many times does 4 goes into 4? One time. So you are going to have 1 times pi, which is pi. Okay, 1 times pi, which is pi, minus how many times does 2 goes into 4? Okay, how many times does 2 goes into 4? 2 times. You're going to have 2 times 1, which is 2. So minus 2, close the bracket. You still have this. Okay, now let's do question 10.2.2. Okay, 10.2.2. Determine the value of x for which the shaded area will be a maximum. Okay, for max. So you are going to take the derivative of the area with respect to x. Okay, the derivative of the area with respect to x. Okay, so you have the derivative of the area with respect to x, like this. Okay, this is equal to, so this is the area of the shaded part. So we are going to take the derivative of this, right? This is a number. Okay, you have pi minus 2 over 4. This is a number. You can isolate it like this. Okay, because this is a number. And then you have x to the power of 4. So you have the exponent is 4 and the coefficient is 1. Okay, 4 times 1 is 4. And then times x to the power of 4 minus 1. Okay, you subtract 1 from the exponent. You're going to have 4x cubed. Okay, when you subtract 1 from the exponent. Okay, let's carry on. You have negative 2, which is the coefficient, and 3, which is the exponent. Okay, so you have 3 times negative 2, which is negative 6. And then you have x to the power of 3 minus 1. Okay, you subtract 1 from the exponent. You're going to have negative 6x squared. Okay, when you subtract 1 from the exponent. Let's carry on. You have the coefficient is 1 and the exponent is 2. So you have 2 times 1, which is 2. Okay, you are going to have plus 2x to the power of 2 minus 1. Okay, so you subtract 1 from the exponent, which is plus 2x. Okay, when you subtract 1 from the exponent, right, you have x to the power of 1. Okay, so you close the bracket. Let's carry on. So after taking the derivative of the area with respect to x, you are going to take the derivative, you equate it to 0 so that you can find the value of x. Okay, so you have this, right? You equate to 0 and then try to solve for x. Okay, so that will be your answer. Okay, let's solve for x. You're going to divide by this number on both sides. When you divide by this on both sides, on this side, this will cancel. You remain with this only. This is equal to 0 divided by this. You have 0. Okay, so you divide by this number on both sides. You get this. Okay, you carry on. You are going to take what is common in this. Okay, so you have 2x there, and you have 2x there, and you have 2x there. Okay, so 2x is common in this bracket. Okay, so you can take 2x outside of the bracket. You open the bracket, you remain with 2x squared, so that when you multiply the two terms, you are going to get this. Okay, and then you carry on, you have minus 3 because you need to get 6. So you have 2 times 3x. Okay, x times x, you're going to have x squared, and then plus 1. Okay, if you multiply 2x by 1, you get this. Okay, so you close the bracket. This is equal to 0. Okay, you can carry on. You can factorize this bracket. Okay, let's do that. You have 2x, and this bracket, you can factorize it like this. Okay, So you have 2x times x, right? This is going to give you 2x squared, and you have 1. You can factorize this as 1 times 1, okay? And then you are going to have the same sign as what? As negative, okay? Because you have positive there, you are going to have the same sign in both brackets as what? As negative, okay? So if you are struggling with factorization, I'm going to make some videos in which I explain how to factorize. Okay, for now, this is what you get. Okay, let's carry on. Now you have 2x is equal to 0. From this, you know that x is equal to 0 when you divide by 2 on both sides to solve for x. Okay, and you have this bracket is also equal to 0. Okay, this bracket is equal to 0. From this, you know that x is equal to, when you take negative 1 to the right, it becomes 1. You divide by 2, so you have x is equal to a half. I hope you can do that. Okay, let's carry on. And you have this bracket. This is equal to 0, right? This bracket is also equal to 0. And from this, x is equal to 1. When you take negative 1 to the right, x is equal to 1. Okay, so you have this, this, and this. So from the question, you can see that x is in between 0 and 1. Okay, x is not equal to 0. X is not equal to 1. Okay, so the value of x is in between 0 and 1. Not equal to 0, not equal to 1. Okay, so we can cancel this. We can say not equal to 0 and not equal to 1. So this is the only value, because a half is 0.5. 0.5 is in between 0 and 1. Okay, we are done with question 10 from May, June 2021 from DBE. Until next time, I will talk to you soon.